Okay, in this lesson we're going to be introduced to significant digits and specifically accuracy, how that relates to accuracy. So again, we need to look at some definitions. The accuracy of a measurement refers to the number of significant digits. So this is because that definition uses significant digits, we're going to really need to focus on what we mean by significant digits. Okay, basically, the greater the number of significant digits in a measurement, the better the accuracy, and vice versa. So we know that they're definitely related. I think if we just look at a couple examples, that's going to help us zero in here a little bit. For example, the average distance between the moon and the Earth is 239,000 miles. Well, how exact do we think this measure is? And I'm going to use the word exact here for a little bit. And when I'm looking at it, is it exactly 239,000? No more, no less mileage? Probably not. And what leads us to believe that this is not very exact? The fact that we have these zeros in here kind of tells us that probably this is rounded off to 239,000. But if I would have had 239,009 miles, now that I put another digit here at that last place value, now I'm starting to think that, maybe this is, this might be far more exact because I've got a digit here at the end that is not zero. But here where I have nothing but zeros on the right end, I'm thinking this is probably rounded. So we know that there's something to do with the zeros here. Gives us some information about how exact a measure is. So that's one of the rules that we want to take a look at. But really I want to focus on this particular measure, 239,000 miles to the moon. The accuracy here is 3 significant digits. So these digits would be significant. You're right, the zeros are not. So let's examine all the rules that have to do with whether or not a zero is significant. We're going to apply these rules to a couple other numbers and really get practicing this. Digits other than 0 are always significant. So up here are 2, 3, and 9 were definitely significant. So that first rule there is pretty straightforward. A 0 is significant when it appears between 2 significant digits. So up here, the zeros that I tucked inside there were significant. A better example might be if I just write this over here, 305. So 305, whatever it is I'm measuring, that 0 inside there is going to be significant because it's between 2 other non-zero and therefore significant digits. Okay. It could also be significant if it's at the right end of a decimal number. So if I had something like, and I don't usually put a 0 in front of my decimal just because I don't want things to get too cluttered, but if I had 730,000, that 0 to the right of this decimal digits is also going to be significant. And I feel like I need to kind of explain why that might be. Let's say I've got the situation where this is, and it might be a situation where this number, the actual measure was 7,298 ten-thousandths. And for whatever reason, we need to round this to the thousandth place. So if we'd go immediately to the right, that number is greater than 5, so we'd come back here, and that means we'd have to bounce that up, and we'd have to bounce that up. So this number, if I have to round to 3 place values, would be 730,000. It might be that this number here, that this 0 is actually, it's been rounded to. Or it might be a case where it was, let's say, 7,304, and I needed to round to this place value. So when I go immediately to the right, that digit is less than 5, so I'd come back here and leave it as is. So in other words, in each of these cases, I was needing to round to the 3rd place value or the 1,000th place. It just happened to be that when I rounded it, it came out to be a 0. So whenever you have a 0 to the right of significant digits in a decimal, that 0 is also going to be significant. Or it might be a case where we've got 0 tagged in an overbar. So let's say I had something like 38,000, but I had my 0 that's in this is tagged, in the hundreds place is tagged. That means it's been rounded to that place value, and so I need to count that as a significant digit. So in this case, we'd have 3 significant digits. Very similar reasoning as to what we had up here. It's just that up here, this was a decimal, and the zeros to the right of a decimal, it's going to be significant. Here, it's a tagged 0 and a whole number, and it's going to be significant. Okay, so when is a 0 not significant? When it's at the right end of a whole number. So we had that up here when we were looking at 239,000 miles to the moon. These zeros are to the right of significant digits, so therefore they are not significant. Okay, and then also we have the case when it is at the left end of a significant digit in a decimal number. Like, let's say we had something like, okay, so these zeros are to the left of significant digits in a decimal number, so they are not going to be significant. Okay, so here, item number 2 here we had when they are significant. Item number 3, when they are not, when the zeros are not significant. So what we need to do is we need to practice this a little bit. We're going to find that the whole definition of accuracy has to do with significant digits. So that's really 2 ways to ask you to do the same thing. Find the significance, or the number of significant digits, or find the accuracy. So we're going to take a look at these, and we're going to do it one at a time, apply the rules. So here I have 6 thousandths. So we've got zeros. They are to the left of a significant digit in a decimal number. So these zeros are not significant. So we have 1 significant digit. That's one way to say that. We have 1 significant digit, or we have an accuracy of 1. Okay, here we have 950 volts. This is a 0 to the right of a whole number. So that 0 is not going to be significant. So we have 2 significant digits, or an accuracy of 2. Okay, now we've got a situation where we've got a couple zeros going on. We've got a 0 to the left of a decimal. We know that zeros to the left of a significant digit in a decimal number. I need to be clear about that. It's to the left of the significant digit of a decimal number. So that is not going to be significant, but we've got a 0 to the right of a significant digit in a decimal number, and that is significant. So we have 2 significant digits, or an accuracy of 2. Here we have 0 between significant digits, so that 0 is automatically significant. We have a total of 4 significant digits, or accuracy of 4. Here we have 974. We have 3 significant digits, no zeros to worry about. Here we have 96,000 tons. We have 3 zeros to the right of a whole number. These 3 zeros are not significant. So we only have 2 significant digits, or an accuracy of 2. And here I have a bar over my first 0. It's to the right of a whole number, so that 0 is significant, but the 0 without the bar is not. So we have 3 significant digits here. Here we have 4 significant digits, 2 significant digits. They're very easy when we don't have any zeros to worry about. So accuracy of 3, 4, and 2 here. Now I've got a situation where I need to do some analysis. I've got a 0, but I've got actually 2 zeros here, but I've got a 0 to the right of a decimal, so it is significant. The 4 is automatically significant, so we've got a 0 between 2 other significant numbers, so that 0 must be significant. So this is accuracy of 3, or significant digits, 3 significant digits. I feel like I need to point out, we were using these 2 rules here on that one, the second and the third under part 2. So I guess if we wanted to talk about part 2 of our rules. Okay, here we have a 0 to the left of 2 zeros to the left of significant digits in a decimal number, so they are not going to be significant. So we only have 2 significant digits, or an accuracy of 2. And here we have a 0 to the right of a whole number. It is not significant, so we only have 2 significant digits, or an accuracy of 2. Hopefully that'll get us started as we continue to practice.